All right, welcome back, IB. So now let's start 6.1a. And at the end of this mini lesson, your assignment will be to do 6.1a on page 374. So we're talking about space, and we're talking about relationships in space. 3 dimensions. It's not as scary as you might think. Let's take a look at distance formula. The distance formula in space is this. Distance equals the square root of, yeah, I know that's ridiculously long, x1 minus x2 squared plus y1 minus y2 squared plus z1 minus z2 squared. Oh, you know what? I should have said in 3 dimensions, every point, I think I said this in the last video, every point can be described as an x, a y, and a z value. So the distance between 2 points, look, we're just adding that extra thing there, right? So it shouldn't be that difficult, shouldn't be that frustrating. Midpoint, similar situation. Midpoint formula in space is going to be x1 plus x2 over 2, y1 plus y2 over 2, and that would be in 2 dimensions, z1 plus z2 over 2. That's 3 dimensions. So that's the only difference. We're just adding that extra, the extra coordinate there. That's really all there is to it. All right. Now let's introduce some trig. Well, hopefully not introduce. Hopefully we know some of this. So looking at some the basic trig functions. If we have a triangle, a right triangle, side lengths of A, B, not side lengths, vertices of A, B, and C, and I have a reference angle. Now this is going to be my right angle, so I'm going to call this the reference angle, and I'm going to use this symbol, theta. Later, for unknown angles, we'll also use alpha and beta, or in American, beta, for unknown angles. These are the symbols that are often used to represent unknown angles. All right, so if this is my reference angle, the sides can be named according to the reference angle. This side is opposite from the reference angle. This side is adjacent or next to the reference angle. And this is the hypotenuse, the side across from the right triangle. The first 3 basic trigonometric functions are sine. I'm going to write some stuff down under here in a moment. Cosine, and again I'm going to write some more stuff down under here, and tangent. Sine is often just abbreviated as SIN, and the sine of any angle, that's supposed to be a theta, is the ratio of the opposite side over the hypotenuse. The cosine is often just abbreviated as COS, but we still say cosine, we don't say cos, of any angle, is represented by the adjacent side over the hypotenuse. And the tangent, abbreviated as TAN, but we still say tangent, of any angle, is the ratio of the opposite side over the adjacent side. Now this we know. I think we know all this stuff already. So let's take a look at 2 sample problems that I want to do. 2 problems that hopefully we know how to do from previous classes. And again, if you've had the pre-calc, they're pretty easy. But before moving on to 3-dimensional space, I want to look at 2 sample problems. In a right triangle like this, usually the problems are either going to be to find a missing side or to find a missing angle. So let's look at one example of each problem. First, find a missing side. Suppose I'm given a triangle, a nice well-behaved right triangle, and I tell you that this side is 7, and this angle here is 34 degrees. And I want to find this side right here. I'm going to call it x. Now, can I use Pythagorean theorem on this? A squared plus b squared equals c squared? No. Why not? Because I don't know that side. So I have to use trig on this. Well, as I'm using trig, I'm going to look at the problem, and I'm going to ask myself a couple of questions. What do I got? What do I need? What's going to give it to me? What do I got? I've got an angle and the adjacent side. What do I want? I want the hypotenuse. What uses an angle, adjacent, and hypotenuse? Cosine. This is a cosine problem. The cosine of any angle is the adjacent over the hypotenuse. All right, so I ask myself, what do I got? What do I want? What's it going to give it to me? I write down the identity, substituting in. The cosine of 34 degrees is 7 over x. Now, the cosine of 34 is just some number. We're going to do that on a calculator in a moment. If I solve for x, cross multiply, divide, I'm going to get x equals 7 over the cosine of 34 degrees. On my calculator, now notice I'm using degrees. Later we're going to be measuring angles in radians. So I want to make sure that my mode, I'm in degree mode and I was in radian mode, so make sure you change it. Go to your setup, Casio users, make sure you change that, otherwise you get the wrong answer here. So I'm going to do 7 divided by the cosine of 34, and I get that the hypotenuse is 8.44 units long. The little u represents units because if I'd said inches or centimeters, I would have that units down there. All right, the other type of problem is find a missing angle. So let's take a look at another sample problem. This time I'm going to tell you that this side is 12, this side is 8, and I want you to find the missing angle, and I'm going to call it alpha. We ask the same questions. What do we got? What do we want? What's going to give it to us? What do we got? We've got the opposite side and the hypotenuse. What do we want? We want the angle. What do I use for that? What uses an angle, opposite, and hypotenuse? Sine. This is a sine problem. So I'm going to say the sine of any angle is the ratio of the opposite side over the hypotenuse. So the substituting in the sine of my unknown angle alpha, I can reduce that. 4 goes into both of those, is 2/3. So now I need to ask myself, well, what angle has a sine of 2/3? Now I do that by using arc sine. I'm going to take the arc sine of both sides. The arc sine of both sides, or the inverse sine, and they cancel each other out. I'm going to introduce the whole to the -1 power. I know most of you realize that already. I'm staying away from it right now, and I'm using the words arc sine to kind of emphasize because I don't want to get confused with reciprocals. Arc sine and sine cancel each other out. So I get alpha equals, the angle equals, the arc sine of 2/3. All right, how do I do arc sine on my calculator? Well, I'm going to go to second sine. And you can see the -1 exponent. Arc sine and sine to the -1 really are the same thing. Of 2/3, 2 divided by 3, is 41.81-ish, and that's in degrees. So my angle is going to be 41.81 degrees. And if I'd been in radian mode, the answer would be in radians, and we'll talk more about angles later. All right, so hopefully nothing new so far, right? Nothing new. All right, here's where it's going to get a little crazy, ladies and gentlemen, because now we're going to apply this. We're going to move these into 3 dimensions. Into 3 dimensions here. All right, so here's the problem that I would like to do. I want to find the measure of angle ACE in the following diagram. All right, so let's see if I can draw this diagram down. It's going to be a box here. I'm going to have top, and I'm going to have all right, so let's see. A, D, C, B, H, G, F, and E are my vertices in my box. So 3 dimensions. There it is, my 3-dimensional box. ACE. Where is angle ACE? Angle ACE, here's side AC, and then EC, oh, I wish I had a ruler. Do I have a ruler somewhere around? I could have sworn I had a ruler somewhere. I need to get better prepared. I got a little card I'm going to use. There we go. And what I want you to do is I want you to see that the angle is inside of this box. Oh gosh, and let's see. Well, in order to find the angle, I'm going to need to know some dimensions of the box. So let's say that I tell you that the box is 4 centimeters by 3 centimeters by 2 centimeters high. Now we've got enough information. Now we can find ACE, the measure of the angle. Now, really, focus on the triangle here. ACE, this triangle. Let me draw the triangle over here. I've got the triangle AEC, and this is the angle. I'm going to call it alpha. That's the one. That's the angle right here inside that box that I'm really interested in. Now, do I know any of the sides? No. This side right here would be the diagonal of the base. This side right here would be the diagonal of the cube. This side right here would be the height of the cube. Oh, wait a minute. I know that. It's 2. The height of the... Oh, I know that. That's 2. Do I have enough information to find alpha? No. I need at least one more thing. I either need to know this length here, the diagonal of the cube, or this length here, the diagonal of the base. I think I can find the diagonal of the base. Notice this little triangle here. It's a little right triangle in there. Draw the little right triangle in that's in here. I'm going to orient it a little bit differently just so we can kind of emphasize it, that this is D, C, and A. And AD is 4. DC is 3. Nice, well-behaved Pythagorean triple, isn't it? So a squared plus b squared equals c squared, 3 squared, 4 squared, 9, 16, 25. This side is 5. AC is 5. This length here is 5. The diagonal of the base is 5. Now, do I need to find the diagonal of the cube? No. Could I? Yes. Quite easily. Do it in my head. 25 and 4 squared root of 29. I want to find that angle right there. All right, so we're going to go through the same questions. What do I got? What do I need? What's going to give it to me? I want to find that angle, and I know the adjacent and the opposite. All right, what uses an angle, adjacent and opposite? Tangent. This is a tangent problem. The tangent of any angle is the ratio of the opposite side over the adjacent. Substituting in, the tangent of alpha is 2/5. Take the arc tangent of both sides. And alpha equals the arc tangent of 2/5, which is shift tangent 2/5 21.8. In other words, 21.8 degrees. So 3 dimensions is going to be a little bit new, a little bit getting used to it, working with it. The homework, there's going to be a lot of just kind of cranking through using the new formulas to find pieces, a couple of word problems in there, another problem very similar to this. So the assignment that I want you to do right now is I want you to go and do assignment A, 6.A, which is on page 374. I want you to do problems numbers 1 through 7. All right, guys, if you've got any questions, put them in the post section, and I'll answer them, and then we'll move on to 6.1b, where, again, we're going to be working with 3-dimensional shapes, some things familiar from geometry, and some new things along the way as well. But I think we'll be okay. And then as we start getting into more of the trig stuff, you know, it doesn't really get that crazy. And in some ways, it is not as hard as the pre-calc trig stuff. You know, we will see de Moivre and vectors and all that stuff later, but right now this is going to be our first entrance into the trig and basic geometry. And other than the 3-dimensional space, I don't think this is going to give anybody a hard time. I think you guys will be fine. All right, good luck, and I'll talk to you again soon. Bye.